Hello, my name is Inaya and I'm a tutor. I'm going to walk you through this problem. So I saw that you have the formula down, first principles, f of x plus h minus f of x over h. That's good, but it's important to understand where that formula came from. So basically this is just the slope formula. It's going to be hard to write it, but basically, you know the slope formula, y minus y1 over x minus x1. So like the difference in the y's and the difference of the x's gives you a rate, and that rate is shown in the slope formula. So if you compare the two, here I've worked it out, I'm going to explain it. If you compare the two, this is your, h is just resembles the difference between the 2 points on the x-axis. So if we take another point here, this over here is h. And the reason why we keep it a variable is because it's, as we're going to see, we're trying to find the slope at the single point. So we're going to want to get closer and closer and make a smaller distance between these 2 points to make it more accurate, right? And so that distance h is constantly changing, and the way we show that is through a limit. So essentially we want that distance to be 0, because then that'll be really close to being exactly at that point, because you're taking 2 really close values. It's almost like taking at that value, but we can't really do that because we're using the first principles method, which is using slope only. So this is saying the y value of that second point, whatever it is, and this never changes, the first point, because we're keeping that constant, but h is getting closer and closer. And then over the difference between those two. So this bottom is x, that's the h, and that's getting closer and closer. So now that we know that, when we have this formula set up, all we have to do is just plug in h as a variable. And you might kind of get confused because there's so many variables, but at the end, one of them will go away because we're going to plug in 0 for h. So then you'll only be left with an x value function. That's just to show that we're getting left with h. So now that we understand the basics, my technique is that I'll just write the original f of x, right? But I'll leave a gap where the x is, because we know that instead of x, that's going to be x plus h, which is a new variable in itself. It's called x plus h. So we're basically, everywhere the x is, we're accounting for the we're accounting for its second point, which is x plus h. So that's always going to be the same. So all I did was plug in x plus h here. It's really important to keep the parentheses constant, because then you're going to distribute this later. Not now, just to keep stuff simple. But yeah, because it can get confusing. You might write as 4x, and then we might forget to distribute the 4 to the h. So now once you have that set up, to get rid of radicals, we're going to use the conjugate, and this comes from the factoring rule. Oops, I'm on line here. This comes from a plus b times a minus b. So if you want to get rid of something, you know this is going to turn into a squared minus b squared, right? A squared plus ab minus b squared, which is what we want because we want our first term and our second term to get rid of the radical. So, and we don't want a middle term in the middle, right? So this is going to give us an a squared and a b squared. So it's going to get rid of these roots, which is good. So using that setup, we're going to just write the same thing with a plus sign. The first term is going to get squared. Second term is going to come plus this product and then minus this huge product. So they're going to cancel out. You don't really need to write this whole product out. And then you get a minus this second term squared. So when you square, all you have to do is just get rid of the radical because it's the same thing, root times root. Just the radical goes away. And then you're left with a pretty easy polynomial to solve. And you'll see that stuff gets canceled out. Make sure you keep the parentheses, distribute. Now you can distribute because it's easier to see all the parentheses together and there's less terms to work with. And then things start canceling out. You're going to have this huge product at the bottom. And that's basically the thing that you multiply by your conjugate. So that stays the same. So you have to do the same thing on the top and bottom because it's 1, right? You're not changing the properties of the equation. And so this you have to use, I forget what the property is, but they cancel out. you have to just do it one by one. And then, I'm going a little overboard, but the h's will cancel out because they both are multiplicands, right? The h is being multiplied by everything 4, and h is being multiplied by everything. So it's essentially just multiplying a fraction by the whole thing, h over h. So you can just take that out, they cancel out. So then the only place you're really substituting is 0 at this point is inside this radicand. So you're left with 4 over, this goes away because you've now you substitute h once you've simplified as much as you can, just to make things easier. And then you're left with this fraction right here, and I did it the way that someone else did it in the comment, the chain rule, and you get the same answer. I should have solved it, but 4 over 2 is 2 over the square root of 4x plus 3. I hope that helps.